Hi, this is section 10.3 on geometric sequences. So, first is what it looks like, right? The nth term of a geometric sequence is given by an, where you multiply a1 times r to the n minus 1. Okay, so that means that r is a common ratio, okay? Common ratio given from either the problem, right, they give it to you, or from in between any two terms. So a2 divided by a1 gives you r. a3 divided by a2 gives you r. a50 divided by a49 gives you r. Okay? Just make sure to always put the one up bigger, not the bigger term, but the bigger n amount, right? The further along term on top over the previous one. All right, so an example of this is here, where we go from 3 to -6 to 12 to -24. At first, it doesn't look like this has any connection necessarily, but it does have a pattern because remember, we're not thinking about differences anymore, we're thinking about ratio. So if we took -6 over 3, we get -2. If we take 12 over -6, we get -2. If we take -24 over 12, we get -2, right? So r is -2, okay? You have to look at the kind of ratio that's created. Okay, now, there is kind of this little hint, what if you don't have a1, right? So you can set it up just like we could set it up with arithmetic sequences, that n is k plus n minus k, the k cancels out, you get n equals n, so that a k times r to the n minus k works just as well. All right, so an example here. Find the number of terms in the geometric sequence. Basically, we're finding n, right? Okay, so remember our formula, right? Go back and see what it is. an equals a1 times r to the n minus 1. So then we have an is equal to a1r to the n minus 1. Okay, so an is the last term. That's 1 over 64 is equal to a1. That's the first term. That's 4 times r to the n minus 1. So let's figure out what r is. We take 2 over 4. We get 1/2. We can take 1 over 2. We get, well, 1/2, right? So 1/2 is our common ratio. So 1/2 to the n minus 1. Okay, now get this part of the term on its own. So divide by 4 or multiply by a fourth, something, right? So we have 1 over 64 times 1 over 4 is equal to 1/2 to the n minus 1. Let's use an exponent trick, right, of getting same base. So 64 is 2 to the what power? Well, 64 is 8 squared. 8 is 2 cubed. So if we had 8 squared and then we have 2 cubed, well, that's 2 cubed, which is squared then. So that's 2 to the 6th, right? Times 1 over 4 is 2 squared. Well, when you're multiplying, which we are in the denominators here, you add exponents, right? So this is over 1 over 2 to the 8th. Okay, well, if we have this set up, this is really, well, 1 to any power is 1, so this is really 1 over 2 to the n minus 1. So that means that we have 1 and 1 in the numerators, same thing. 2 to the 8th equals 2 to the n minus 1. So that means the exponents equal. 8 equals n minus 1. So then n is 9, right? So there we go. We just found n, the number of terms in this geometric sequence. Okay, next example. We're given a4 and a7. Find the common ratio, r, okay, and the value of a1. All right, so let's think about that formula we have. We know that AN is equal to A1 times R to the N minus 1, right? We can do the same thing for AK. So AN is equal to AK R to the N minus K, right? So then AN we're going to say is A7. So we have 0.009375 is equal to AK, which we're going to say is A4, so 0.075 R to the N is 7, K is 4, not 5, is 4. So then we have 0.009375 divided by 0.075 is equal to R to the third, right? So we'll do this in the calculator, right? That we have 0.009375 divided by 0.075 is equal to 0.125. That's R cubed. Then we take the cube root of both sides, right, to get just R. So that would be 0.5 in the calculator, okay? So there's R. There's the first thing we wanted to find. Now we want to find A1. So let's use A4. So A4 is 0.075 is equal to A1 R, which we know is 0.5 N minus 1. So N is 4 minus 1. So 0.075 is equal to A1 times 0.5 to the third. Well, we know what that is. That's 0.125. Then divide, so A1 is equal to 0.075 over 0.125. So A1 is equal to, well, that's 0.6 in the calculator again. Okay, so there's A1. We needed to find R and A1, and we did that. Okay, next is the nth partial sum of a geometric sequence. So, given a sequence with first term A1 and a common ratio R, we can find the nth partial sum, the sum of the first n terms, right, by this setup. Okay, generally we use this second version here just because it's a little bit more concise, just because we have A1 times 1 minus R to the n over 1 minus R, where obviously R can't equal 1 because, well, then it would be 0 in the denominator. And, well, S1 is very uninteresting because that's literally A1, right? So, well, we don't need to do a sum for that. That's just A1. So that's why we don't use S1. Okay, so then let's see, let's use this. We want to find the sums of these formulas. So let's see here. We know Sn is A1 times 1 minus R to the n, all divided by 1 minus R. So let's rewrite that. That's Sn is equal to A1, 1 minus R to the n, all divided by 1 minus R. So let's figure out, first we have to figure out what R is and what A1 is. Well, A1's easy enough on this first one. That's just 3. So A1 is 3 for this first one. Now, if we take the second term, 3 times negative 1/3 over the first term, 3. Well, the 3's cancel. We get negative 1/3. If we do the second term, or the third term divided by the second term, that's 3 times negative 1/3 squared over 3 times negative 1/3. Well, the 3's cancel, and we have 2 negative 1/3 over 1 negative 1/3. So one of them cancels, and we get negative 1/3. So our ratio is negative 1/3. So r is equal to negative 1/3. So then we can set this up. S n, well, first we want to figure out also what n is as well, don't we? So if we know that a n is equal to 3 times negative 1/3 to the 4th, and that's equal to a1, which is 3, times r, which is negative 1/3 to the n minus 1, well, the 3's can cancel. Then we have negative 1/3 to the 4th is equal to negative 1/3 to the n minus 1. So 4 is equal to n minus 1. So then n is 5. Okay, so then we can set this up. S5 is equal to a1, which is 3, times 1 minus r, which is negative 1/3 to the 5th, over 1 minus negative 1/3. So that's then a plus. So then S5 is 3 times, well, let's see here. We have negative 1/3 to the 5th. So three to the 5th is 243. So this is 1 plus 1 over 243 over, well, this is 3/3 plus 1/3, so that's 4/3, right? So then S5 is equal to 3 times, well, 1 plus 1 over 243, that's 244 over 243, times, let's multiply by the reciprocal, that's 3/4. So then we have 9 over 4 times 244 over 243. This can simplify some before we try to put it in a calculator, or if we don't have a calculator, right? 2 goes into 244 and 4, leaving us with a 2, and a 122 goes again. So that leaves us with 66. No. 61. So then 3 goes into both of these once. Let's see, that would be 81. We can take another 3 and get 27. So now we have 61 over 27. And that's all we can do, right? That would be our sum of S5. So just to clear this up, this one here is equal to 61 over 27. Okay, so next I need to make myself a little bit of room, so I'm going to subtract some of this here. So first off, we need to find what? Well, the formula has a1, so we need to find a1 for this first, or the second one here, right? So that means we have 4 to the first. Well, that's 4. Then we need to know r. Well, let's find a2. So then that will give us our common ratio, right? So a2 is 4 to the second, so that's 16. So if we take 16 divided by 4, we get 4. That's what this is. That's the common ratio right there, okay? So r is 4, and we know then n is 7, because that's that top number. So that means S7 is equal to a1, which is 4 times 1 minus r, which is 4 to the n, which is 7, divided by 1 minus r, which is 4. So we have 4 times 4 to the 7th. So that is 1 minus 16,384 over negative 3. So that's 4 times, let's see then, that's negative 16,383 divided by negative 3, so those will cancel. And then this is 4 times 5461, which is 21,844. So that means that this is equal to 21,844. Okay, and those are both of our answers for that one. All right, now we have something a little different. Now we have infinite geometric series. Okay, this is when we want the sum of every single possible term. All right, it simplifies it down a little bit. Now it's only a1 divided by 1 minus r. All right, again where r doesn't equal 1, obviously. Okay, so our common ratio, meaning not equal to 1, meaning the terms change, right? Because ratio of 1 would be, well, the same term over and over again, right? So notice here we also have one other qualifier, that r is less than 1, okay? Meaning the terms are getting smaller, all right? So if the terms get bigger, r is greater than 1, no finite sum exists, because it keeps getting bigger and bigger and bigger and bigger and bigger infinitely. Well, that just gets bigger always then, right? So we have no set sum. This one, it's basically you're adding a number that's here, then you're adding a number that's here, if we're kind of on a coordinate plane, then we add a number that's here, and then here, and then here, and here, and here. You see, we get closer and closer to 0 as we go, right? So that means as we add these, we get close to a certain specific number. That's what this formula does, okay? So let's practice with this. So this time, when it's infinite sum, we just take a1 divided by 1 minus r. We don't have that 1 minus r to the n term anymore in the numerator. All right, so these are infinite because, look here, we have the ellipse that just says dot, 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 okay, and forever, right? First thing we need to do, though, is find r, because if it's greater than 1, there's no finite sum, right? So we have 2 times negative 2 squared over 2 times negative 2, right? That's the second term divided by the first term. So the 2's cancel, and then a negative 2 cancels, and we get negative 2. That's less than 1, so we're good. A 1 is equal to, well, 2 times negative 2 is negative 4, so let's figure this out. S infinite sum is equal to a1 negative 4 over 1 minus r, which is negative 2. So that's a plus, so we get negative 4 over 3. That's our infinite sum, negative 4/3. Who knew, right? Okay, now on this one, let's figure out our a couple terms so we can calculate r. So a1 is equal to 5 times negative 4/5 to the first power. So our 5's cancel and we get negative 4. So let's find a2. That's 5 times negative 4/5 squared. So that's 5 times 16 positive over 25. So 5 cancels and we get 16/5. And then let's figure out r. So we have 16/5 over 4, which is over 1, right? So multiply by the reciprocal. 16/5 times 1 over 4. Well, 4 cancels, and we get 4/5 as r, which is less than 1. So we're good. Okay, so the infinite sum here would be equal to a1 is negative 4 over 1 minus r, which is 4/5. So negative 4 over 5/5 minus 4/5 is 1/5. So that's negative 4 times 5 firsts, so that's negative 20. So our infinite sum there is negative 20. All right, next example. Now here we want to figure out if these are arithmetic, geometric, or neither, okay? So what we want to do now is think about what arithmetic and geometric talk about, right? So an arithmetic sequence has a common difference, right? You're going up or down by a certain amount. A geometric series has a common ratio, okay? So either look to see if in between each term has a certain increase, right? Or if in between each term has a certain common ratio. Okay, so let's look at this first one. Always try arithmetic first, it's the easiest one. 3 to 10, that's 7. 10 to 18, that's 8. 18 to 25, that's, what is that, 7 again? So that's not a common difference. Let's then think about the ratio. So 10 over 3, let's just leave that alone. Then 18 over 10, what does that simplify to? We can cancel out a 2, so that would be 9 over 5. That's not the same thing. So this would be a neither, right? Because it didn't have a common difference or a common ratio. Now the next one. We go from 27 to 22, that's down by 5. 22 to 17, that's down by 5 again. 17 to 12, down by 5. Well, right there we know it's an arithmetic then because it's a common difference. Now, this one, you can just look at it and know that one does not have a common difference, right? 5 to 50, then 50 to 500, and 500 to 5,000, definitely not. Kind of looks like it might be a geometric though, right? So 50 divided by 5 is 10. 500 divided by 50 is, well, 0 cancels, 5 cancels, 10. Check it one more time. 5,000 divided by 500. 2 zeros cancel, cancel the 5, we get 10. So, common difference of a ratio of 10. So it is geometric. All right, so that's how we want to look at those. Now, another example, but continuing in that same theme, is figure out if it's arithmetic or geometric, and then find the formula. Okay, so let's see here. 13 to 20, always think arithmetic first, again, right? 13 to 20, that's 7. 20 to 27, that's 7 again. Looks like it's arithmetic. Okay, so then let's see here. Arithmetic setup. What did that formula look like? That was AN is equal to what? Well, A1 plus N minus 1 times D, right? So that means AN is equal to, the first term is 13 plus N minus 1 times the common difference of 7. So there we go. Okay, now we want to figure out the next one. Is it arithmetic or geometric? So 3 to 6, that's 3 difference. 6 to 12, that's 6 difference. It's not arithmetic. So 6 divided by 3 is 2. 12 divided by 6 is 2. So it's geometric. Just make sure on that one, even though you only have 2 options. So now remember the formula for geometric. That's AN is equal to A1 times R to the N minus 1, right? So AN is equal to, A1 is 3, R, we've just figured out was 2, to the N minus 1. And there's your formulas. And that is the end of the lecture for section 10.3.